Hello everyone, my name is John Capobianco and I've just released a new tool that I wrote with my collaborator Devin Sloan called Mind Network Map or Mind nMap. The repository can be found on GitHub/automateyournetwork Mind nMap. Now here's the logo that I want to thank the community for. I did a kind of hatchet job and they provided me this amazing logo. But let's get started. And the whole idea here is that you can drive this from an open DevNet sandbox. And we'll go through those steps. But let's take a look at the README and how you can get started here. Now we recommend a Python virtual environment, and it does depend on Cisco's open source PyATS library and parsers, and the MarkMap utility. This installation guide is written for Ubuntu, and you can run this on WSL to Ubuntu, which is what I'm going to be doing. That's not to say this won't work with Alpine or non-Debian based systems, Rocky, CentOS if you're still on CentOS, etc. But you'll just need to make sure that you install the pip package for Python, get PyATS installed, and then Node.js and the MarkMap utility. So again, we're going to set up a Python 3 virtual environment. We're going to activate that environment. We're going to clone this repository, which you can copy this line from here, or you can hit code clone here. And then inside of that environment, we're going to install PyATS full, update our Ubuntu, install npm, and then install the MarkMap CLI. There is an example of a single device or a topology. This is built from a core distribution access perspective, but if you just want to map a single device, you can do that as well. We recommend that you encrypt your passwords, and we put a link here to the secret strings formula from PyATS. But if you're not keeping this in a GitHub repo, you could keep your string in the naked there. But if you go to production with this, it is strongly recommended you encrypt your passwords. Now, we use the custom tag role in the topology. This role is normally not in a testbed file, but for our case, we want to, and I'm going to patch this, we want to tell each device what their role is in the topology so that it maps correctly. Now, what we need to do is just run the PyATS job against the testbed file that we've made for our topology or single device, and then we have these mind maps. At the bottom, we link to the dependencies, the PyATS, and you should get familiar with that, as well as the MarkMap utility, and you can try it yourself in the browser. And then we have try it yourself. So if you go to the topology in the sandbox, I didn't want to break away from my README file. I have it open here. And in the top left, look for CML, and you can reserve this sandbox. Now, what we're going to model or mind map in this topology is just the access layer. This CSR1000V doesn't parse correctly, but we can parse both of these distribution switches. And let's go ahead and do that together right now. So I'll show you how to do this. From here, right, you followed the instructions from the README file, and you've gotten to say, the point down here. This is the testbed file that you're going to use for this topology, right? So from here, right, from your main repo, we can type, right, we're going to be in the Mind nMap folder, type code period to launch VS Code, and then all you need to do is simply copy in the contents of the CML sandbox over top of the mind map and save it. Now, I'm not going to push this up to the repository. I'm going to abandon these changes. Once that is done, again, the command itself to run the mind map utility is found in the README file. And, right, so if we follow along with these instructions, we have to get into the mind maps folder, And then you can simply copy this line, and it's a PyATS run job command. I'm going to maximize the screen, and we'll see the magic here. We're going to connect to those two devices and parse multiple show commands. And they don't all have to parse successfully, but we'll get a table of the results of what we've parsed. We store the data, meaning make the markdown file and generate an HTML page. Then we disconnect from the devices gracefully. Here is our summary, and we did have a few fail. There is no LLDP neighbors, right? So that failed because there's no LLDP. That's fine. Now back in our repository, if we go to the output that it generates, we go to the network folder, devices, and you can see that there is a switch01 MD file. Now this is pretty neat. We can look at this as a markdown file, right? All this is a markdown file. But if we turn on the MarkMap preview, and again, to get that, you go to extensions, look for MarkMap, and install the MarkMap extension. It will give you the MarkMap button on the file here in the corner. And let's take a look at the mind map for this switch. And again, I don't know anything about this switch, and we can recenter, we can zoom with a click, we can wheel mouse in and out. Now let's just collapse interfaces and make this a little more consumable. So from the top, we have the serial number, device type, version, operating system under the device information. We have a full device inventory. It's a 9000V chassis with this serial number. It has slot 1, the Ethernet module, a couple of fan slots, and that's it. Now, VLANs, check this out. It has an active VLAN 1 with a bunch of interfaces on it, right? All of these interfaces are on VLAN 1. VLAN 101 is active with these interfaces on it. And we can kind of see which, VLANs are on the device if they're active and the interfaces on the VLAN. Pretty neat. It doesn't have any VRFs, but we would have a similar breakdown of VRFs. Now let's look at neighbors. This has a CDP neighbor of disk switch 02, right? And we get the serial number and the device host name. It's a Nexus 9KV. The local port is management 0 and the remote port is management 0. That's where it's picking up this neighbor from. It has these MAC addresses, but we break down MAC addresses by the VLAN that they're on. Pretty cool, right? There's no ARP because it's a layer 2 switch, but if this was a layer 3 router, we would have ARP information. And then the interfaces didn't seem to parse correctly, but that's okay. I'll come back to that. So again, it's an open sandbox. It's not perfect. It's really meant for a core distribution access. The other thing I want to highlight is that you get an HTML file that you can right-click and, I'm missing the extension. Let me show you a handy extension. It's called Open in Default Browser, this one. And why? Okay, so it is enabled. Where's my HTML page? I should have an Open in Default Browser. Okay, well that's not working. I see, it thinks it's a Django file. Well, I'll just do this the long way. We have that in an HTML page as well, that same markdown file that you could host on an Apache server somewhere and give your users access to the mind map. So again, to recap, the new tool is called Mind nMap for Mind Network Maps. It takes a PyATS testbed and turns it into a series of mind maps per device and an overall topology if you have a core distribution access layout. I'm here to help. I recommend that you start with a single device or start with the DevNet sandbox. But please reach out to me if you need any help getting this tool going. Thank you.